All right, let's finish up with 5.1. We got a concept summary here. We've been talking about solving linear equations. We've looked at simples. We've looked at multi-steppers. We have to do more than one thing or a couple of things in order to solve. We've looked at variables on both sides. You have to get the variable on the same side and get the constants on the other, and then get the variable by itself. We've even looked at weird situations where the variables disappear and you get a number equal to itself. You get an identity, and so it is infinite number of solutions when that happens. And we've looked at whenever your variables disappear and you get a number that doesn't equal another number, and that's a no solution situation. But we've got some steps here that kind of outline how to solve any linear equation at any time. You need all of the steps sometimes, and you need some of the steps sometimes. Sometimes you can skip some of them because there's not a thing there to do. But let's look at a modeling problem. Let's look at a real-life word problem scenario here. When word problems and modeling are going to be the same with this book. The boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. Okay, we're going to have to create the equations because they didn't give them to us, it looks like. But we know what we're going to do. We're going to be solving linear equations. Something is going to be set equal to something else. It's going to have an x. And so we have to find it. So we know a boat travels upstream. So here's my stream. Here's my boat. Okay. It's a sailboat. It goes this way. It goes this far in 4 hours. This is a distance. And it comes back. It takes 2.8 hours. And it's 3 miles per hour faster. Miles per hour, that is a rate or a speed. Okay. And we can relate distance. You should know about relating distance. Distance is equal to the rate you are going times the time it takes you. The rate or the speed, right? That's your rate or your speed. And our distances are equal. So our rate times our time should equal the other rate times the time. So let's set up an equation. We need a rate for the first time. Well, the first time, our rate was, we don't really know. That's kind of what we're looking for. Our rate was some distance over 1 hour. And our time was, it took us 4 hours. And then the way back, now that changed a little bit. Our rate was some distance plus 3 hours times our time, which was 2.8. We want to get those to equal. So, the 1 just goes away. You get 4x. And here, the 1 kind of goes away because when you divide something by 1, it's itself. But we're going to multiply the 2.8 in. So we get 2.8x plus 3 times 2.8. Let's do that one real quick. That would be 4, 2, 6, 7, 8. 84 with a decimal place. We got one hoop. We do one hoop. So 8.4. We're going to move the 2.8x. I'm running out of room. Let's see, 0.2 makes 3, so 1.2x equals 8.4. And we're going to divide those by 1.2. So how far did we go? Well, let's see, 8.4 divided by 1.2, move the decimal, okay. 12 goes into 84, let's see. 12 times 8 is going to be 90 cents. Let's see, let's try 7. 7 times 2 is 14. 7 times 1 is 7 plus 1 is 8. Hey, look at that. So our x was 7 miles. That's how far they went. Now this is a tough problem because you got to know the distance formula. You got to know what it is for distance, how to find distance, rate times time. Okay, we have to know to set our distances equal to each other. Okay, well, that's the only thing that's going to be equal in this. The time was different. The speed was different. What's the same is they went upstream this much and they went downstream that much. So it's got to be distance. Okay. So once you get the equation parts and you know that it's rate times time, well, our rate is how far by how long. Well, we don't know what the speed is, so we just do it over 1. The speed on the way back was the speed we started with, but plus 3 miles an hour, so we take x plus 3 on top, right? And then we can solve for the rest. So work on those word problems, developing those equations, figuring out how to